Hello, today we're going to get into esterification reactions. We're going to go through essentially how this reaction works and the products that it makes. And as you could probably guess, esterification reactions are how we produce esters. So an esterification reaction is a type of condensation reaction. I should explain what that means. Condensation reaction means that I'm making some kind of product that's a byproduct, that's a small molecule. Water is a typical one, condensation, but you could have other small ones, like for example, HCl being produced as a product or ammonia or something like that. So in a condensation reaction, we have a small molecule byproduct that's made in addition to the products that we're really trying to make. So it occurs when a carboxylic acid reacts with an alcohol to form an ester and water. Usually a small acid catalyst such as sulfuric acid is used to increase the rate of this reaction along with some careful heating. So sulfuric acid is the typical catalyst for this reaction. So you remember that for a catalyst doesn't get used up. So it's present when the reaction is occurring, but at the end of the day, I have the same amount of catalyst at the end as what I started with in the beginning. It's not a reactant. What it does do is it lowers the activation energy for this reaction, and as a result, the chemical reaction occurs at a faster rate. So here's an example. If I have a more general kind of formula, I guess would be a better way to put this. If I have a carboxylic acid and an alcohol reacting with sulfuric acid present, then I get an ester and water. It is always water for esterification. That's the byproduct in this condensation reaction. So here's an example. If I take propanoic acid and I react it with ethanol, the propanoic acid is going to react with the ethanol so that I end up getting a water being produced. Now this O right here for the alcohol is going to be connected to the carbon that had the carboxyl group on it. It's losing this hydroxyl with the H from the alcohol, and now this O is connected to this carbon, and that's how I get the ester. So I end up with CH3, CH2, CO, CH2, CH3. Now this can get tricky, and it's really important that when you do these, you actually draw this line. So you draw the line from the O of the hydroxyl group from the alcohol, and you draw that line straight to the carboxyl carbon. Okay, so the carbon that has the double bond O and the OH on it from the carboxylic acid. And then if you do that, you now know how things are connected. And then you just lose this water, the OH and the H in the middle, and now you're all set up. So here's another example where we can predict the products and name them. So I have butanoic acid and methanol. So I've got this O is going to be connected now to this carbon, and that happens by losing this OH and this H to make water. So what we'll do is we'll draw the ester that it makes. So I've got this CH3, that's the first one from the butanoic acid right here, to a CH2, to a CH2, to my carboxyl carbon that now is an ester functional group. So I've got this carbon, the carbonyl. I've got now an O, so I'm on this O right here, which is now connected to a CH3. Now I didn't mention that this is called the ester functional group, right? Right here. We did this last day when we talked about naming esters. And of course, I also have now HOH, which came off of this in this reaction. So I have my water. I'll label that right away. Now for this, I have the alcohol portion of the ester is a methyl. So the name is methyl. Then I have a space. Then I have 1, 2, 3, 4 carbons in the carbonic or carboxylic acid portion of this. So it's methyl butanoate. Then it asks, what odor does this ester have? Well, this actually would end up being an apple flavor. You don't have to know that. There's no way for you to know that from the structure. This comes from the information that you did previous, where you had that table that had the different flavors and then showed you the different structures. So let's make up another example on the fly here, just because I think it's important for us to kind of try to predict some structures of some esters based on this. So let's say I had ethanoic acid, so CH3 to C, double bond O to OH, and ethanoic acid is used a lot in these reactions. So I have ethanoic acid, and then let's react this with something a little bit different. So let's say we have my OH to a carbon here, and this has a CH3 attached to it. CH2, CH3, and then let's pop another CH3 on here. So this would be called 1,1-dimethyl propanol. So that would be my alcohol structure. So if I'm reacting these two in the presence of sulfuric acid, I'm going to connect this carbon. Let's go with a different color here. Why not? We're going to connect this carbon over to this O. So that's going to be my connection. And then this OH and this H is going to get lost as water. So what I'm going to end up with, and I'll start by drawing my carboxylic acid portion, so CH3 to the C, double bond O, and then I have this O, which is connected to a carbon, to a CH3, to a CH3, to a CH2, and then to a CH3. So this is the structure that I'm getting, and then of course water. I should probably do one more after this where I kind of go through a little bit more complexity in terms of where that hydroxyl group is, because this is still laid out the exact same way, which makes it look easy. So this now has, and I'm actually going to have a really similar name to what I had, 1,1-dimethyl, because that is carbon number 1. So 1,1-dimethyl propyl. That's the alcohol portion of the ester. And then ethanoate is the carboxylic acid portion of the ester. And then I have water as well. So that's another example where I'm connecting it. Now we're going to go to something a little bit more complicated, because I have regrets in that example that it was too easy with how it was laid out. So what we're now going to do is something like this, where I have an alcohol first, CH3 to a CH. This has an OH on it. CH2, CH3. You'll see in a moment why this is more complex. And in fact, let's even add another branch on here. Let's put a methyl on there just like that. And then I'm going to react this with CH3, CH. Let's put a CH3 here. And then my carboxyl group, CO, and then an OH. All right, cool. So what do I have in terms of actual names here? Well, for this alcohol, this would be carbon number 2. I want that lowest number possible. So I have 3-methyl butane 2-ol for my alcohol name. This is carbon number 2 for carbon parent chain, and then my methyl will be on carbon number 3. This is my branch right here. And then for this carboxylic acid, I have 2-methyl propanoic acid. I got my space there in between propanoic and acid. All right, so now I'm reacting this in the presence of H2SO4 as a catalyst. So now going again to my other color, what's going to happen is I am connecting this alcohol O, and this is where it kind of gets a little bit crazy. This is connecting to the carboxyl carbon. So it's going to be connected right there. And then I need to trace through my connections to make sure I get this right as I'm drawing my structure. So I'm going to start with my carboxylic acid portion of the ester. I have CH3 to CH to CH3 to the carbon to the double bond O. Okay, so I just copied that out. Now I'm going to here. So now I'm connecting to this O. So I have a connection to this O. I'm right here right now. This is connected to a CH. Okay, so I can draw this CH right here. Now I'm going to connect this to a CH3. I'm going to put that up top or down below. It doesn't matter, but this is kind of more of a branch. And then I'm connected to this CH. Okay, which is connected to a CH3. And then I have a branch as well on the CH, so let's draw that up as well, just right up here. And then I can't forget the water. I like drawing that right away before I do the naming just to make sure I don't forget about it. It is easy to forget. All right, so now I got to name this beast, and it's quite the doozy. I have a methyl on carbon 1 and on carbon 2. So I have 1,2-dimethyl. And then this is 1, 2, 3 carbons long, so propyl. And then now I have 1, 2, 3. It's a 2-methyl, so 2-methyl propanoate. Okay, and that's my ester name. All right, so that's how you do esters. Hopefully that makes some sense and that works out. You got some practice in your workbook to try. Have a good rest of your day.